Welcome. In this video, I'm going to show you how to find a particular solution curve. So we're given the differential equation y prime equals x over 2y, and we're given that we need to find the particular solution at the point 1,4. Okay. So the first thing we're going to do is we're going to make this as dy dx equals x over 2y. Then we're going to isolate the dy and the dx, one on each side. So 2y dy x dx. Then we're going to integrate both sides, and then we get 2y squared over 2 equals x squared over 2 plus c. Then we cancel this one, we get y squared equals x squared over 2 plus c. Then what we're gonna do is we're going to multiply everything by 2, so we're gonna get rid of these 2. So the way we do it is like this: 2y squared equals x squared plus 2c. Then when we arrange the equation, we're gonna get 2y squared minus x squared equals c. We're gonna call 2c's and we rename it as c. Okay, so all we're left to do right now is to find, this is the general solution curve. Now we're gonna find it for this particular point. So we're gonna find a particular solution. So to find c, we plug in this into here. So to find c, we're gonna plug in 2 4 squared minus 1 squared equals c. Then we have 4 squared, 16 times 2, that's 32, minus 1 equals c, so c is equal to 31. And then we plug it into here, we get 2y squared minus x squared equals 31. And that's the particular solution. This is the particular solution curve. And that's what we were after. So when they ask you to find a particular solution curve, you need to find the general solution and then find c and any other variable, any other constant that you're missing given the initial condition. Thank you very much. That's all I wanted to teach you on this video. Don't forget to subscribe.